Right, in this example, we're solving tan squared theta equals 1 plus sec theta. Answers to one decimal place between 0 and 360 degrees. First thing I notice is we're in degrees. So calculator, make sure it's in degrees mode. Very important that you check that before you press any trig buttons on the calculator. Right, I've got tan squared and there's also sec in this question. So there's an identity that links together tan and sec. So that identity is 1 plus tan squared x is sec squared x. That's what I'm going to use. So rearranging that and using theta instead of x, I can replace tan squared theta, so replacing the left hand side here with sec squared theta, take away 1. And I'm going to leave the right hand side alone. Now I have a quadratic equation in sec theta, so let's rearrange it into a nicer format. In other words, that format that format, so it equals 0, and we've got the squared term, then the linear term, then the constant term. It might factorize, it might not. This one does factorize, so that works. Always expand to quickly check. Even if you can do it in your head, then even better. Does that give us what we had before? Yes, it does. So sec theta is either 2 or minus 1. Let's turn these now into cos. So if sec theta is 2, that means cos theta is a half. If sec theta is minus 1, that means cos theta is 1 divided by minus 1. Simplify that immediately. It's also minus 1. Both these are possible, so we will get solutions from both of the two possibilities. I'm going to do the cos theta equaling a half first. A quick sketch of the cos graph between 0 and 360 will help me to do this. There we go, there's 0 to 360. I'm solving cos x equaling a half, so 1 half will be about there. We can see we're going to get a solution which is acute and a solution which is reflex. So there'll be one solution between 0 and 90, and there'll be another solution between 270 and 360. If we do inverse cos of a half on the calculator, or you might know this one, it's one of the common ones. Inverse cos of a half is 60 degrees. So that is 60 degrees. Using the symmetry of the graph, that is 60 to the right of a maximum point. So this other one at the end is going to be 60 to the left of a maximum point. Makes that one 300. Another way of looking at it, you could say the first one was 30 to the left of where it crossed the theta axis. So the other one's going to be 30 to the right. So 30 to the left or 30 to the right. Just using the symmetry and features of the graph. The other one, where does cos theta equal minus 1? Well, we can see from the graph there's only one place where that happens. So 180 degrees will also be a solution. I don't know why it says to one decimal place, because they're all exact, so I'm just going to get rid of that. It shouldn't have said to one decimal place. So theta is, and you don't have to write these in ascending order, any order will do, 60 degrees, 180 degrees, and also 300 degrees as well. And hopefully you've got time in the exam, you could put each of those back into the original equation and into both sides, and if you get the same number, then you know they are correct.